How about confidence intervals? We can use this result to construct confidence intervals about the true mean as well. So for example, if for the cloud seeding experiments, n1 is equal to n2 is equal to 26, so n1 plus n2 minus 2 is 50. Our test statistic, we're using a t-distribution with 50 degrees of freedom. Our confidence interval, we're looking at what would happen on a t50 distribution. So here's a t50 distribution, looks a bit like this. It is centered on 0. How many standard errors away from the true value would you expect to get 95% of the time? Okay, what's the value for the number of standard errors you would expect to get away from the true value of some parameter 95% of the time if it's got a t50 distribution? We can ask MATLAB. We go tinv. Okay, so do we do tinv 0.95? We don't, because tinv always gives us the area to the left of some value. So it tells us the value that has a particular area to the left of it. And if we want 95% in the middle, we want 2.5% off the bottom and 2.5% off the top as well. So there's like 2.5% there. So we want to find a value that has 97.5% of the distribution less than that one. And on MATLAB, tinv of 0.975, the second argument is 50 because we've got 50 degrees of freedom. We get an answer of almost exactly 2. It's 2.01. So if you had 52 observations and you calculated a sample mean difference, 95% of the time you'd expect to get within about 2.01 standard errors of the true mean difference. So if you want to construct a confidence interval for the true mean difference, you're going to go sample mean difference minus t star, in this case 2.01, standard errors. Up to sample mean difference plus t star, in this case 2.01 standard errors, times the standard error of sample mean difference. So there you go. We've used this result to derive a method for testing hypotheses about mean difference and for constructing confidence intervals about mean difference under those 3 assumptions that we needed for this result, under the assumptions of independent random samples from normal distributions with equal standard deviation.